Okay, so here's where we're at right now. So the data that I sent out was the first two titrations. So here's the basic idea, is that you had the burette and you had 0.1 molar solution in there, so you knew the molarity of the sodium hydroxide. And the first thing that you had in there was that 25 milliliters of acetic acid, and that was just straight acetic acid, okay? There was nothing else with it, it was just straight acetic acid. So they measured it, they did the titrations, all this good stuff. Now, even though I'm not asking you to actually do this, but on that first curve, even though I don't technically ask you to do that, but what you should be able to do, if you just have the data from that first curve, is that you should be able to realize, oh, here's the equivalence point, okay? And from that, you could calculate the molarity of your acid if you wanted to, because you could use MAVA equals MVVB. You should be able to realize, oh, I can go to half the equivalence point when it's half neutralized and get an experimental value of my pKa. So that's what we did on that first lab. So like on this test that's going to be coming up, that's what I'm going to expect you to be able to do. It's like if I gave you this graph, so okay, here's my equivalence point, here's my half the equivalence point, I use that to get my pKa value. Okay, you don't have to, but I'm just telling you, that's what you have to be able to do, right? Now the second one is that you added a specific mass of sodium acetate to it, and then you had to calculate what that theoretical pH is going to be. Now here's the bigger idea that you have to understand of what's going to happen, is that Mother Nature likes to be in equilibrium. So it's some hydronium ion times some anion concentration divided by HA. So initially, okay, and here's the shift that you have to make. Initially, when you set up that rice chart, this was at 0.1 molar, this was 0, that's 0, minus X plus X, boom, you all know the drill, okay? You're going to get your theoretical pH. So that should be old school. You should not even have to give that a second thought about how to calculate a theoretical pH based upon a Ka value and the initial concentration of your acid. That should be able to be done without a second thought, okay? Now what happens is that you're going to overload this with some anions, okay? So you're going to add some sodium acetate to it. Now here's the bigger picture that you have to get. Mother Nature still wants this exact same Ka value because that's when Mother Nature is in equilibrium, okay? That's the mindset of Mother Nature, to be in equilibrium. So what happens is that you increase the concentration of these anions, where these don't start at 0, okay? That's the big shift. This does not start at 0. Now you've overloaded this with some anions, right? And you're still going to add X to it, but now what's going to happen is that whatever that concentration of the anions here, that's going to be the concentration of your anions down here, okay? So what's going to happen is that because you're starting off as a bigger concentration here, that means you have a smaller concentration of your hydronium ions, and this is the important part. The concentration of your hydronium ions goes down because you still want the exact same Ka value, okay? So initially, this was an equal split between the two of them. But because you've overloaded it with anions to start with, your hydronium ion concentration goes down, but then conversely, your pH goes up because you're taking the negative log of a smaller hydronium ion concentration, okay? So that's the dichotomy. As your hydronium ion concentration becomes smaller, your pH actually becomes higher. And this is the whole key, is that you want this exact same Ka value. Now, what you all need to do for the third titration is that you all need to figure out what mass of sodium acetate you need to add to 25 milliliters of a 0.1 molar solution of acetic acid so that you can start with a pH of 6, okay? So that's that third calculation down there on the bottom of the front page. So check with me before you do that, because if that number is wrong, that third titration is just screwed right from the get-go, okay? Now, obviously, it's going to take more mass than the calculation on number 2, because that only raised the pH to about 4, okay? That third calculation, you want that pH to start at 6. Now, here's the bigger idea. If you look at that Henderson-Hasselbeck equation, pH equaling pKa plus the log of your anions of your HA. So the pKa of acetic acid is 4.87. So the only way that you can end up with this pH being 6 is if the concentration of your anions here has to be bigger than the concentration of the acid, because that makes this thing positive, and you're going to add that to 4.87. Okay? So what you get here out of this part has to be a positive value that you can add to this, and you end up with a pH of 6. Okay? That's the whole key. So that's what you want to be able to think through. Now, in terms of the lab, where'd my lab go? I just had it. I sort of got my organizational skills suck today. Okay. So when you get to this last page of questions, okay, late night with the dreaded chemistry teacher, and it was late when I was writing those questions the first time I wrote this lab. I'm basically going to take you through a series of calculations. Now, what you want to pay attention to, especially when you get to 5, 6, and 7, okay? So if you look in the sequence of questions on 5, 6, and 7, number 5, you're calculating the pH after you've added 15 milliliters of a 0.1 molar solution of sodium hydroxide. That was the initial one that was not a buffered solution, okay? There was no buffering to it. When you get to question number 6, that's going to be buffer number 1, okay? So that's after you've added that mass of the sodium acetate to it. And when you get to number 7, that's going to be, that's that second buffered solution where you're going to start with a much higher value of pH. So make sure when you hit 5, 6, and 7, and the same thing is up there on 1, 2, and 3, that you keep track of which solution you're dealing with, okay? Because that was the whole point of titrating 3 different solutions. Okay, when you get to 9 and 10, down there on the bottom of that page, number 9, you want to calculate the mass of ammonium chloride to produce 25 milliliters of 0.2 molar solution, and then 25 milliliters of 0.2 molar solution of sodium acetate. If you get those numbers and you want to ask me ahead of time, hey, are these values right or wrong, I will tell you, because if those values are wrong, then what's going to happen next is going to be wrong, okay? So when you get 9 and 10 done, ask me and I will tell you. Now, when you get over to questions 11 and 12, all I want, I'm not necessarily looking for like the actual pH values, because this water is notoriously a little bit acidic just from the get-go, so you don't get the true results that you would get theoretically. But here's what basically I want you to see, is that on number 11, you should see a shift in the pH, and number 12, you should see a change in your pH. It's not going to be a dramatic change, but you should see a change in that pH, okay? And I'll tell you now, on number 11, just in case this goes south, okay, which has been known to happen depending upon the quality of the water we're getting out of the DI system. So on number 11, you should see the pH go down. On number 12, you should see the pH go up, okay? So that's theoretically what should happen. And 95% of the time it goes like that, but there's a 5% of the time it doesn't. So depending upon, maybe you have some residue in your beaker or the water that's coming out of the DI system, that's theoretically what should happen, okay? Just saying. Okay, other than that, you are on your own. So here's what you need to do, okay? Do that third titration, okay, do the mass calculations, do that third titration, get that done, okay, because I got to share that with the people from yesterday. And then do those mass calculations for the ammonium chloride and the sodium acetate and run those. Then after that, that's all you actually need to do in the lab. The rest of it becomes a series of calculations and questions to answer. When you do that pH graph, okay, you're going to have 3 different lines on there. Make sure I know which one is which, okay? If you want to color code them, if you want to make them a dashed or just label them, I don't care. But just make sure, because you're going to put all 3 on the same graph, make sure that I know which one you're doing. Now, on your ring stands, you're going to see a little piece of red tape, and it's going to tell you which solution bottles they were pulling out of. Okay, because I had my kids in here yesterday. So if you're using a ring stand that was used yesterday, you're going to see a little piece of red tape that's going to tell you which sodium hydroxide bottle to pull from and which acetic acid bottle to pull from. That way we're using that same data. You should have already some sodium hydroxide in the burette, so but you might have to fill it up to 50 to start it. Okay, so you might have to do that. When you get done, thoroughly rinse out those burettes, especially to run water through that valve mechanism at the bottom, okay? So that I don't have any sodium hydroxide left in there gunking up the system. And then put the burettes back up there, wash everything, and we're done. Okay, so here's the sequence for next week, okay? You got a quiz on Monday. On Monday? Yeah. This lab is due on Monday. Tuesday and Wednesday are train wrecks, okay? I would love to be able to make you all do some stuff, but I guess you get the days off, which kind of sucks, but anyway. And then we're back Thursday and Friday, and everybody is live. We're all going to be back together, okay, on Thursday and Friday. And then, did I talk to you all about the options on lunch?
Yeah.
Okay, all right, yeah. So
you talked about it in the video anyway.
Yeah, because that's an option during lunch when we go back. Because that's what I am most concerned with. Is I'm not so much concerned with kids in the classroom, but I am concerned at lunch, because you all will be sitting close to God knows who else, and you won't have your masks up and everything like that. So my room and that room next door are open if you want to come down here and have lunch. Because this is what I told the admins, like. Nerds of a feather flock together. These kids will probably be having lunch anyway, because that's what you all are, is a bunch of nerds. I'm okay. I'm the biggest nerd in the room. I'm okay with that. If you don't believe me, look at the Twitter picture that I sent out yesterday. So, Riley liked it. You gotta admit, that was kind of cool.
It was pretty good.
It was pretty good. It's me sitting like my Bernie Sanders mittens, and but in front of like the Mars rover. So, anyway. It was cool, okay? It was cool. You guys are just jealous.
Berg is cool.
All right. Okay. All right. So let's go do science.